Hello students, I hope you are enjoying the lessons that is already posted. And the last class we have seen this mixed problems on mole concept. Now in this video we are going to see the next one, how to apply mole concept on a chemical equation. We know mole concept can be applied on chemical equations. Now the number of moles of each reactant and product that is in a reaction can be found by applying the mole concept. The moles can be converted into volumes as well as mass. Example, we have a reaction here, Mg, magnesium reacts with the dilute hydrochloric acid, giving magnesium chloride and hydrogen. Now applying mole concept, the reaction shows here Mg, this is 1 mole. And 2 HCl means there are 2 moles here. Okay, and magnesium chloride MgCl2, this is 1 mole, because there is only 1 MgCl2 and 1 hydrogen, so this is also 1 mole. Now we can convert this because magnesium is a solid. It cannot be converted to volume. We can convert it into mass. 1 mole of magnesium means 1 into molecular mass of magnesium, which is 24. Okay. So 1 mole of magnesium, that is 1 into 24 grams of magnesium converted into mass. Now 2 HCl, this is an aqueous solution, it is a dilute acid. So here again we can convert it into mass, that is 2 into molecular mass of hydrochloric acid. Hydrochloric acid, the molecular mass Cl, chlorine is 35.5 and hydrogen is 1. So and adding you get 36.5. So we can say 2 into 36.5 grams of hydrochloric acid is reacting. Same way the product side, magnesium chloride, MgCl2. This is 1 mole, so 1 into Mg. Mg is 24. 24. This is Mg. Mg is 24 plus Cl2, that is 2 into 35.5, that is 71. 71 plus 24. So you can add, this is coming 95. Okay. So 1 into 95 grams of magnesium chloride. Now this one, hydrogen, it is a gas. Hydrogen is a gas, it is 1 mole of hydrogen. So 1 into, so since it is a gas, we usually don't calculate mass on this. We convert it into volume, molar volume. We already know that 1 mole of any gas at STP has a volume of 22.4 liters. So this will be 1 into 22.4 liters. I think you got it. So this is how we can convert or apply mole concept to a chemical equation. So from this equation we understand 1 into 24 grams of magnesium reacts with 2 into 36.5 grams of hydrochloric acid. That will give a product of 1 into 95 grams of magnesium chloride and a hydrogen gas which will be 1 into 22.4 liters. Now suppose we know the weight of any one of this substance or even the volume of hydrogen. Any one of these 4 parameters is known. We can calculate the other. Okay, how do we calculate that? See this magnesium. Suppose you say you have taken only 6 grams of magnesium. Okay, so if this is 6 grams, so what is this? This will be taken as X and you can take this one as Y and this one as Z. So 6 grams of magnesium reacts. How much hydrochloric acid is required? That you can simply take a ratio, just divide this. No? So that is 1 into 24 upon 6 is equal to 2 into 36.5 upon X. That is it. You cross multiply, you will get the value of X. X into 24 is equal to 2 into 36.5. Now this 6 will go that side, it will become into, it go to the numerator. Okay, and this X has come this side, 6 has gone there. So this is it. Now from here you can find what is X. X is equal to 2 into 36.5 into 6 upon 24. 24 has come to the other side. So simple mathematical problem. Now don't multiply or divide till you reach the last step. Now once you get the last step, these values easily get cancelled. So this becomes 4 and these 2 and 2 will get cancelled. This is 2. Now 2 and 36.5 will be 18.25. So the answer will be 18.25 grams of hydrochloric acid required. So this way you can find out Y also, you can find out Z also. I hope you are understanding how we can apply mole concept on a chemical equation. Now I have some problems, I have questions which you can solve and understand this further. Okay, so here is the first question. This question says dilute sulfuric acid reacts with iron as follows. Calculate the mass of sulfuric acid used in this reaction and the mass of iron 2 sulfate formed. Also find the volume of hydrogen released at the same time being measured at STP. Assume that 2.8 grams of iron is reacted. Okay, so this is well set. Now the equation is here. First check if the equation is balanced. It has to be balanced, then only calculations will come correct. Okay, it is balanced already. So let us write the number of mole. This is 1 mole and this is also 1 mole. This also is 1 mole and this is also 1 mole. So very simple equation. Since all the moles are 1, now we can convert the atomic masses. Usually in the question they give the atomic mass Fe. Fe is equal to, the atomic mass is 56 and hydrogen is 1 and sulfur is 32 and oxygen is 16. All the atomic mass, it will be given in the question, don't worry, so you don't have to memorize them. Okay, so it will be given. Now here we will apply 1 mole of Fe means Fe is 56, so 1 into 56 grams. Okay, weight in grams. And H2SO for 1 mole is 1 into sulfuric acid. You have to calculate the molecular weight. H2SO4, that is H, 2 hydrogens are there, so 2 into 1 is equal to 2. And sulfur, there is only 1 sulfur, so 1 into 32, that is equal to 32. And oxygen, there are 4, so 4 into 16, that is equal to 64. Okay, so when you add this, what will you get? You will get 98. Okay, so 98 is the molecular mass of sulfuric acid. So 1 into 98 grams of sulfuric acid. And this side you have FeSO4. Now you don't need to calculate all the values, you only have to find out what is asked. In this question, calculate the mass of sulfuric acid. So this is required. And also the mass of iron 2 sulfate, that means this mass also is required. So 1 into, what is the mass of iron 2 sulfate, FeSO4? Fe is 56 and sulfur here is only 1, 32. Oxygen 4 into 16, that is equal to 64. So let us remove this and add this. So when you add this, what you get? 152. Okay, so 152 is the molecular mass of FeSO4, 1 into 152 grams, right? And the hydrogen, also find the volume of hydrogen release. It says in the question, so that means you will find this 1 into 1 mole of hydrogen at STP is 22.4 liters. So everything is there now. Now what is given there? What are the things we have to find? Calculate the mass of sulfuric acid. This is required, X. And what about, then they are asking the mass of iron 2 sulfate. Let us take it as Y. And then they are asking the volume of hydrogen released at the same time measured at STP. So let us take this also as Z, X, Y, Z. Now what is this side you have? Assume 2.8 grams of iron is reacted. 2.8 grams. Okay. So it is, now the ratios are set. Now you can find out what is required. First, calculate the mass of sulfuric acid. So number 1, mass of sulfuric acid. Okay, how do you find it? It's equal to, what do you do? 1 into 56 upon 2.8, as I already said, 2.8. This is the ratio. That is equal to the next ratio, that is 1 into 98 upon X. So from this, what you get? 56 into X is equal to, X goes to this side, and this side you have 98 into 2.8. 2.8 goes to the other side. Okay, so 1 we are ignoring. So what is X? X is equal to 98 into 2.8 upon 56. Now let us cancel these figures and what you will get. So 2.8 and 56. this will be 20. Okay, and 20 and this 98 will be 49, 4.9. So the answer is 4.9 grams of sulfuric acid. Okay, it's so simple. Everything will be solved in the same line. You don't need to do a lot of things. And you should understand the ratios usually get cancelled. So don't multiply or divide before reaching the last step. Okay. Now the second part of the question says the mass of iron 2 sulfate formed, that is mass of FeSO4. That is, how do you find it? Now we will take up this first ratio. This is both sides are given, and so we will take FeSO4, these two. This we have used for calculating sulfuric acid. Now this ratio will be used for calculating FeSO4. Okay, so iron 2 sulfate. So that is 1 into 56 upon 2.8 is equal to this one, 1 into 152 upon y. Okay, got it now. So now what is y? Y is equal to this side. Y, that is 56y. 56 is already there. 56y is equal to 152 into 2.8. So what is y? Y is equal to 152 into 2.8 divided by 56. So the ratio is brought. Now final step is reached. Now you can start cancelling 2.8 and this will be 20. This always goes cancel. Now one thing you have to understand, the given value, both sides are given in this. So this is in a proportion. So this will always get cancelled. So remember that 20, this will be divided by 20. So it will be 76. And since it is 20, it will be 7.6, that is equal to 7.6 grams. This answer also has come. Now there is a third part asked here. The third part of the question is find the volume of hydrogen. That means we will be using this one, the last one, okay, with the first one. So the third part of the question is volume of hydrogen. Okay, so what we will write the ratio again, the same ratio here, that is 1 into 56 upon 2.8. 1 into 56 upon 2.8 is equal to, this is being equated with the last part, that is 1 into 22.4 liters upon Z. So 1 into 22.4 upon Z. Now from here let us cross multiply. That is 56Z is equal to 22.4 upon, 22.4 into 2.8. Okay. Now what is Z? Z is equal to 22.4 into 2.8 divided by this 56 comes here, 56. Okay. So that is equal to, let us cancel. As I said, these two will cancel definitely. So this will be 20. Okay, and these two will also cancel. So 2 will be 11.2. So it will be 1.12, 20, because there is a 0. Okay, 1.12. So answer is 1.12 liters. Remember that this is volume of hydrogen. So it is in liters. So I hope you understood this problem. Now I have one more question here. Let us solve this one. Chlorine reacts with aqueous sodium hydroxide as follows. Sodium hydroxide and chlorine are reacting. The products are here. Calculate the mass of sodium hydroxide used. Mass of sodium hydroxide used is asked. Mass of sodium chloride and sodium hypochlorite form. Also find the mass of water form. All weights here. And this one is in volume. This is a gas. Now I think this is not asked. Volume of chlorine taking part in the reaction is 2.24. Okay, this volume is given. So let us take this is 2 moles. This one is 1 mole. Chlorine is 1 mole. Sodium chloride also is 1 mole. NaClO is 1 mole. That is sodium hypochlorite. Water is also 1 mole. Okay, only sodium hydroxide is 2 mole. Now atomic masses in this. So sodium Na is 23. It will be given in question always. Please remember that. Oxygen is 16 we know. Hydrogen is 1 and chlorine is 35.5. Okay, so applying this, let us find out the mass of sodium hydroxide. Okay, sodium hydroxide Na is 23, oxygen is 16, and hydrogen is 1. So on totaling you get 40. So this is 2 moles of sodium hydroxide, 2 into 40 grams. Okay, and here you have chlorine. Chlorine is 1 mole, that is 1 into 22.4 liters. Okay, converting it into volume in liters. And sodium chloride NaCl, Na is 23, chlorine Cl is 35.5. On adding, what you get? 58.5. So this is 58.5 grams. And sodium chloride NaClO, that is NaClO, let us calculate. Na is 23, Cl is 35.5, O3, sorry, NaClO, it is oxygen, so it is 16. So on adding 0.5, 74.5. Yes, 74.5. 74.5 grams. And water, oxygen, hydrogen, oxygen is 16 to hydrogen, so 18 grams. Now from the question, what is given? Volume of chlorine taking part is, this one is given, 2.24 liters. So this is the ratio available to us. Now the rest we have to find. So let us take it as X, this one as Y, Z, or maybe another alphabet P you can put here. So accordingly you can calculate. So 2 into 40 grams, 1 into 22.4, this is X, this is 2.24, what is X? That is how we are going to calculate. So what is asked here? Calculate the mass of sodium hydroxide. So the first question is mass of sodium hydroxide. So let us write mass, number 1, mass of NaOH. Okay. So how do you take out? Let us take out the ratio from this equation, that is 2 into 40 upon X. 2 into 40 upon X is equal to, this side you have, the given ratio is 22.4 upon 2.24. 22.4 divided by 2.24. Okay. Now from here, let us find out what is X. So cross multiplying, you get 2 into 40 into 2.24 is equal to 22.4 into X. So what is X? Bring this one here. That is 2 into 40 into 2.24 divided by 22.4 is equal to X. Okay. So these two can be cancelled. 2.24 and 20, this will be 10. So this 0 and this 0 gone. So what is remaining? X is equal to 4 into 2, that is 8. So 8 grams of sodium hydroxide. Okay. Now second part of the question. What is asked in the second part? The second part is find the mass of sodium chloride. Okay, sodium chloride. So we will take mass of NaCl. So here the ratio is, we will take NaCl, this one, and this is a standard value given, that is 22.4 upon 2.24 is equal to, here what we have, 58.5 upon Y. 58.5 upon Y. Okay. From here, what is Y? Y is equal to 58.5. This will go to the other side, reciprocated, into 2.24 upon 22.4. So these are gone as usual, 10, and this 10 will be divided here. So that is equal to 5.85 grams. Okay, that is done. Now third part of the question is find the mass of sodium hypochlorite, NaClO. So you write mass of NaClO is equal to, how do you find? Again, the same ratio will be written, to 22.4 upon 2.24 this side is equal to sodium hypochlorite is here 74.5 upon Z. 74.5 upon Z. Okay, so what is Z? Z is equal to cross multiplying 74.5 into this goes reciprocated there 2.24 upon 22.4. So as usual, cancel it. 10, this 10 will be divided here, so it will be 7.45 grams. Okay, so the third part is done. Now the fourth part, the last part of the question, I think. Also find the mass of water produced. Mass of water. So mass of H2O. How do you find out? The ratio will be taken again 22.4 upon 2.24. Okay, 22.4 upon 2.24 is equal to this one, last part, no? 18 upon P. Is equal to 18 upon P. Okay, now what is P here? So P is equal to cross multiplying 18 into 2.24 upon 22.4. This will go as usual 10. So dividing 18 upon 10 is equal to 1.8 grams. So that is how we have solved all parts of this question. I think you have understood this. Now please try these questions again and again. And if you have queries, you may write in the comment section, and you may like the channel, and you can subscribe so that the further videos that I post will also reach you. Thank you for watching.